Hello, good morning. Again, this is Engineer Ernesto C. Prudenciado Jr. and welcome to my channel. Let's continue to our discussion in engineering mechanics. Last time we discussed about parabolic cable, but today we will move on and discuss catenary cable. Okay, so what is catenary cable? The definition is the cable sags due to its own weight. The cable assumes the shape of a catenary, which is a graph of the equation y equals the hyperbolic cosine of x. Example of this cable is the power line cable, wherein the cable sag due to its own weight. Okay, so if you can see in the on-den area, there is a power line, no, from NGCP, and the cable as sag, if you can observe. So that is due to its own weight. The only difference of this catenary cable is the load is along the path of its curve. So between the parabolic cable is that the parabolic cable, the load is within the horizontal. Again, the catenary is following the equation of y equals hyperbolic cosine of x. So let's define the elements of the cable. Okay, so x1 is the horizontal component from the support A up to the lowest point here. Again, x2 also is from the lowest point of the cable up to the support B. S1 is the length of the cable from the left segment, okay, of this figure, and S2 is the length of the cable within the right segment of this cable. The sag of this left element is called D1, okay, this one, while the sag of this right element, okay, or the other half, is D2, okay. So the sag, by the way, is computed from the support, the level of the support horizontal, up to the lowest point of the cable. Okay. There is a directrix because this is following the equation of y equals cosine hx, or y equals hyperbolic cosine of x. So there is directrix, if you recall in your analytic, of this equation. C, okay, is the distance from directrix to the lowest point of the cable. So this is in our analytic geometry called the vertex. Okay, and measuring from directrix up to the support A is what we call y1. Okay, and from directrix measured up to support B is denoted as y2. So hope you understand the catenary cable, the difference between the last topic we discussed about parabolic cable. Okay? Okay. So let's go to the formulas to be memorized. We have H here. This is the tension of the cable in the lowest point. So at the vertex, it is equals to the load per unit length of the cable times the C. Okay, C is the vertex to the directrix. Okay, so T1, or the support of this left support at point A, okay, is equals to the load per unit length times Y1 is 1. Okay, it is just the same to the right support. So also T2 is just the y here, or the vertical distance is y2. Of course, we should pair this. So the tension at support A, T1, this one in the left side of the segment, that is square root of h squared plus ws1 squared. So h is the tension at the lowest point, w is the length per unit length, and S1 is the length of the cable. Okay, so the same with the right segment. So let's go to Y1 squared is equals to S1 squared plus C2 squared. So the sag at the left support, or in getting this the distance from the support to the directrix, this is called Y1. So the formula is Y1 squared equals S1 squared, the length of the cable at the left segment, plus C2, okay, the lowest point to the directrix. So this one, other formula is X1. X1 is the horizontal distance at the left segment, is equals to C ln of S1 plus Y1 over C. Okay? Now, if you ask me where the formula came from, so the derivation of the formula is quite long. This is from integration. So I will not do it here. Okay? The only thing that came from a force polygon is this one, the tension at A. So let's go to example. So catenary cable. Example problem number 8. A catenary cable shown has a weight of 215.82 Newton per meter. It has a tension of 300 kilonewton and at its lowest point of the cable. So if you can see, the cable is symmetrical. So it's quite easy if the cable is looks like this, no, symmetrical. So the question is find the sag of the cable. Second is find the tension of at B. So this one, the tension at the support. So of course, TA and TB is just the same because this is symmetrical, as I've said. Number 3 is find the total length of the cable. Okay, let's solve. So I just copied the formulas involved, no, from our discussion so that we can easily look at the formulas and evaluate what formula to use. Okay. So in our problem, the given is the x1 and x2, so total of 500. So since this is symmetrical, so of course x1 and x2 is both 250. So it's half of the 500. Okay, so let's write that as given. So given here is equals to x1 equals 500, I mean 250 meters. I will not consider anymore the right segment of the cable because this is symmetrical, so this is just the same answer. So for whatever is the result we get from the left support. Okay, so let's consider x1. Other given is the tension, or the T or H given is equals to how much? 300 kilonewton. Okay. Next is the W, or the small w. The load per unit length is 215.82. 215.82 kilonewton. Let me see the unit. Kilonewton per meter. Okay. So these are the givens. So the first question is find the sag of the cable. So what are the sag of the cable? So D1. Okay. So let's draw first. So this is the drawing. So the first question is, what is the sag? So the sag is this one. So that is T1, or let's just call it as D. So let's call that as T. Okay. Okay. For looking at the figure, so we can solve D. Okay. D is equals to Y1 minus C. Okay, so this is our equation 1. Okay, so based on the given, we will find what's the best formula to use. So we have H, we have W. So maybe this one, the first formula, we can use that to solve for the C. Okay, so H equals WC. H is given. H is 300 kilonewton. W is 215.82. So we can solve for C. C is equals to 300 so 1.39. 1.39. So by the way, no, I just figured out that the unit of W is not kilonewton. Yeah, this is so big. This is Newton meter. Okay. Yeah. So the answer is this is kilonewton. So we will divide this by 1000 times C. C equals 0.82. So C is 390.05 meters. Okay. So we have now the distance of C. Okay. Next is to solve for Y1. Looking back at the list of the formula, so the only formula here that involves Y1 is this formula, no? This one and this one. So let's use first this because we have x1. So x1 equals ln c. So x1 equals c ln s1 plus y1 over c. Okay. So we have here x1 250. C is 1390.05. ln of, we don't have S1 plus also Y1. Okay, so this is the unknown, and C is 1390.05. So we can solve S1 plus Y1. Okay, so what is the answer? So let's just store this ship store A. $250 equals alpha A times ln alpha x over alpha A. Ship solve. So S1 plus Y1 equals 1663.94 meters. This is meters. Okay. So next is we have this as equation So next is to use this formula so that we can have another equation because we have two unknowns. So y is 1 squared. So y1 squared equals s1 squared plus c squared. Correct? Yes. So we don't have y1 squared. We don't have s1 squared. But we have c. What is c? c is 1390.05 squared. Okay? So now we can substitute this equation. Okay? So let's transform first. S1 equals 1663.94 minus y1. Okay? So this one is y1 squared equals what is S1? 1663.94 minus y1 squared plus 1390.05 squared. So we can solve for y1. Okay. X squared times 1663.94 minus alpha x squared plus 1390.05 squared. Keep solve. So x is 1412.59 meters. Now we can solve for C. We can solve for D. From equation 1, okay, so D equals y1 minus C. Okay, so no, this one, y1 minus C. So the sag D equals y1 is 1412.59 minus 1390.05. So what is D? 1390.05 equals. So the sag is 22.54 meters. So this is the answer. Okay. So for question number 2, find the tension at P. Okay. So it's just the same as tension at A because this is symmetrical. So let's just solve for tension at A. Okay. So what is the formula that can be used out of the list? So this one. Okay. This one. We can use this formula. So we have already H. We have already the W. We don't have the S1, correct? So we have already, we don't have the S1. So to solve for this, we have to solve first S1, okay? Because we have equation here. So equation 2, from equation 2, S1 plus Y1 equals this one, 1663.94, 1663.94. So we can solve for S1 because we have Y1 already. 1412.59, 1412.59 equals 1663.94. So S1 equals 1663.94 minus 1412.59. So this is 251.35 meters. Okay. So if we have this, we can now use this formula. The second formula on the list, T is equals to square root of H squared plus WS1 squared. Okay. So T equals square root of what is H? This is given 300 squared plus this is kilonewton supposed to be. So this is 215.85 over 1000. Right? 215.85. I mean 215.82. 82. Okay. Multiply by S1 is 251.35 meters squared. So we can solve for T. Okay. So let's try to solve this. Square root of 300 squared plus 215.82 divide 1000 times 251.35 squared. So T1 is 304.86 kilonewton. Okay. So this is the answer for question number 2. Okay. So for question number 3, find the total length of the cable. So it's very easy, no? We have already S1. So total length of the cable is just equal to S1. L is equals to S1 times 2 because that is symmetrical. So this is 251.35 times 2. So the answer is 251.35 times 2. So 502.7 meters. Okay, so this is now the answer. So it's very easy, no? If you can memorize the formula. Okay, thank you. Thanks for listening. Bye-bye.